Hello Godosians, this is Andy with an update to my latest project, which is called Digital Logic, and we're going to simulate, we're going to actually teach people how to design electronic circuits, digital logic gates, starting with them, the logic, the numbers, to the logic gates themselves, and then combinational logic to make the actual logic gates and simulate them, and then you create your own little like chips that you're gonna put together to make a computer, at least a microprocessor. That'd be quite amazing, wouldn't it? So here we are. Let's we're in the circuit scene here. Let's play that, see what's going on there. Click on that one to play this scene. So for a simple circuit, we can click on the NOT gate, it picks it up. Look at that, it doesn't place it when you're inside of the picker, but outside it does. So drop it down, let go of the mouse, it drops it. Look at that. And then let's move it, click on it, and then you can move it and drop it down again, and then have an input. There you go. This is an input signal, like imagine a pin on the outside of a Raspberry Pi or that kind of thing. That's what this is. Then we want an output. This is just going to indicate our logic level output. To connect, we hover around the chip, and look at that, we got a blob of green there. That means we can attach a wire. Ooh, it automatically connects when you get over the connection point of the part. We can move it around, and we're using some funny feature of Godot. It's the pathfinding algorithm, the A*2D pathfinding algorithm to connect this point to that. So this thing is this line 2Ds is kind of like, well, it's connecting, but yeah, it doesn't look that great, does it? And again, we can do the same. Look, whee! If I let go there, it will disappear. And do it again, and hover around this chip where you can find a connection point, and it automatically connects. If we want to disconnect, we just click here, and it's gone. See that? There, connected. Okay, now these are sensitive to clicks now for repositioning or changing the levels, because they're input. This is an input node, that one there. If you click on this, nothing happens. If you click there, it'll, ooh, look at that, it made it red hot. That is the logic 1 level, the high level, and it propagates through this NOT gate to invert it to a low level, which is reflected in the color of the connecting wire, and finally to the output node there. So we can click it again, and it should, hey, yeah, it does, it works. It toggles between low and high values, and yeah, because it's got the dual functionality of moving it, sometimes it moves it around. Look at that. The path 2D thing, crazy, huh? I'm gonna put it over there. Whee, look at that. Put it there. Whee. Not too bad, that one. So yeah, it'd be quite nice to improve on the connection stuff, but anyway, it's working. And if we do something crazy like feedback loops, we're gonna crash it out with a, yeah, it's gonna be like a Stack Overflow. Still keep going round and round and round, because this emits signals. Oh, at this point we should check in the code, actually, shouldn't we? How did you do that? Oh, I got this 1080p, so it fills the screen. Yeah, so in the part GD script, we've got we connect signals up, right? So there, when something happens, oh, there's a lot of code here to worm through. Yeah, like indicate state. This is yeah, when the state is changed on an input, it like goes round and round and round. Oh, I better make another video about this. It's getting a bit out of hand here, isn't it? But you get the idea. It's like pretty good. It's like you can lay down parts and simulate the circuits, and then it'd be pretty amazing. Actually, what I'm going to do is you're going to like learn how to make the basic logic gates that are used in combinational logic, such as flip-flops, and that's the basic one, and there's the D flip-flop, and they end up being like memory parts for making memory chips. And there's going to be like counters, sequential logic, where you ripple counters and things like that. And then you'll create your library of chips that after having learned how to do it, how to assemble them from the basic gates, and then create your system, which might be a microprocessor. At least that's my aim. It'd be pretty amazing if I can get that to work. Pretty cool. Anyway, I'm just gonna quit this video now, and then stay tuned for the updates and the new ones, and please subscribe and click on the like button if you like it. See you again.